The clock starts. Now you're scrolling through your phone on an ordinary Monday morning when every news alert fires at once. NASA has detected an asteroid, designation 2026 AX7, hurtling toward Earth at 27 kilometers per second. Impact probability 94%. Time until collision, exactly 7 days. The rock is 180 meters across, large enough to flatten an entire metropolitan area, and there's nothing we can do to stop it. Or at least, nothing we can do safely, reliably, and in time. Not in 7 days. This isn't science fiction. Planetary defense teams run tabletop impact exercises and simulations of scenarios like this, and the pattern is brutal. With short warning, humanity usually loses. In multiple runs with compressed timelines, the outcome is painfully consistent. The physics outruns the politics, and the logistics outrun the science. Right now, astronomers track tens of thousands of near-Earth objects, and the number keeps rising as new surveys come online. But the real danger isn't the ones we've already found. It's the ones we haven't. Especially the mid-sized asteroids, the 100-300 meter class, the region killers. Some estimates suggest we may have found only a minority of them. That means many remain invisible until the geometry is wrong, the lighting is wrong, and the warning time collapses. Within 168 hours, millions of lives will hang in the balance. Every second counts, and the countdown has already begun. First Monday, 6:47 a.m. GMT. The Catalina Sky Survey telescope in Arizona captures a faint streak of light moving against the background stars. Within minutes, automated tracking systems flag the object as unusual and upload the astrometry data to the Minor Planet Center's public database. By 7:15 a.m., the Scout Hazard Assessment System at NASA's Jet Propulsion Laboratory automatically calculates the trajectory. The red flags go up instantly, a 92% probability of Earth impact in exactly 1 week. In the pre-internet era, governments might have had time to strategize in secret. Not today. By 8:09 a.m., bots programmed by amateur astronomers to scrape public telescope data are tweeting the orbital anomaly. Reddit threads explode with trajectory plots. The news isn't broken by a presidential address. It breaks on social media in real time. The asteroid is a rubble pile, billions of tons of loosely bound rock and metal held together by weak gravity. It formed 4.5 billion years ago, silently orbiting the Sun until Jupiter's gravity nudged it onto a collision course with Earth. Now it's 10 million kilometers away and closing fast. In Manhattan, a nurse finishes a night shift and checks her phone between elevator doors. 1 alert, 2, then 20. She sees impact probability and reads it twice, like her eyes must be wrong. Her first thought isn't the asteroid. It's the patients on her floor who can't move on their own. By noon, the White House is forced to acknowledge the reality that the internet has already figured out. At 2:00 p.m., the president addresses the nation. The words are calm, measured, designed to prevent panic. But nothing can prepare 7 billion people for the truth. The sky is falling. Tuesday morning brings refined calculations. Every telescope on Earth reorients toward 2026 AX7. Ground-based radar at Goldstone Deep Space Communications Complex bounces radio waves off the asteroid's surface, measuring its spin, shape, and density. The news worsens with each data point. Impact probability climbs to 97%. The uncertainty ellipse, the predicted impact zone, stretches 4,800 kilometers across the Atlantic Ocean, from the coast of Portugal to the eastern seaboard of the United States. Tens of millions live within the potential devastation zone. No one knows yet which cities will be erased. NASA's Jet Propulsion Laboratory runs impact simulations using probabilistic risk models. At 27 kilometers, 70 times the speed of sound, atmospheric compression will heat the rock to 10,000 degrees Celsius. But this asteroid may be too dense to fully vaporize. Most of it will punch through the atmosphere in under 4 seconds. Scientists calculate 3 nightmare scenarios. Ocean impact. If 2026 AX7 strikes water, it acts like a depth charge, excavating a crater kilometers wide. The resulting tsunami wouldn't be a single surfing wave, but a relentless, surging wall of displaced ocean. Coastal cities from Lisbon to New York would face inundation, timing depending on seafloor depth, continental shelf shape, and exact impact location. Land impact. A ground strike releases energy equivalent to hundreds of megatons of TNT. The fireball reaches kilometers in diameter, vaporizing everything instantly. Thermal radiation ignites fires across a vast area. Airburst. If the asteroid explodes high above the surface, like the 2013 Chelyabinsk meteor, but orders of magnitude more powerful. The shock wave alone flattens concrete structures for tens of kilometers. International space agencies convene emergency sessions. The brutal physics of orbital mechanics eliminate most options. Could we deflect it? No. NASA's DART mission proved kinetic impactors can work, but only with years of lead time, not days. Could we nuke it? A nuclear standoff explosion is often described as the best bet for short warnings, but launching an interceptor, mating it with a warhead, and reaching the target in 6 days is logistically impossible. And then someone asks the question that always shows up in panic room meetings. What if we try to break it apart? The answer is colder than the problem itself. Fragmentation can turn one bullet into a shotgun blast. Instead of one impact zone, you risk multiple. Instead of a predictable strike, you get chaos. Fragments spreading across a wider corridor, some still large enough to devastate cities. By Tuesday evening, the devastating conclusion crystallizes. We cannot reliably stop this asteroid in time. All we can do is prepare for impact. T-5 days, evacuation protocols. Wednesday, 8 a.m., FEMA, NASA, and Homeland Security hold a joint press conference. The Atlantic uncertainty ellipse has narrowed to 2,000 kilometers, centered ominously between New York and the mid-Atlantic coast. The federal government orders the largest evacuation in American history. 40 million people must move inland. Interstate highways transform into one-way rivers of humanity, flowing westward. This isn't just traffic, it is the migration of an entire culture. For a hospital nurse in Manhattan, this means leaving patients who are too unstable to move. She walks past rooms where monitors beep steadily, where someone is sleeping, where someone is awake and asking what's happening. She doesn't have an answer that fits inside a human sentence. For a prison warden in New Jersey, it means deciding what to do with 3,000 inmates. Lock them down and risk drowning them. Release them and risk chaos. Move them and risk losing control on highways already packed with frightened people. For the poor without cars, it means waiting for government buses that might never arrive. Europe faces similar chaos. Portugal, Spain, France, and the UK begin evacuating coastal populations. The global economy enters freefall. Stock markets suspend trading. Money becomes an abstraction in the face of catastrophe. What good is a portfolio if civilization changes shape on Monday? Looters exploit the chaos, but so do heroes. Neighbors share fuel. Strangers offer seats in cars. As the social contract dissolves, human nature reveals itself in its rawest form, both its profound nobility and its darkest impulses. A father in Queens stares at his dashboard. His son is strapped in the back seat with a backpack and a pillow. The highway looks like a parking lot that stretches to the horizon. He isn't thinking about the asteroid anymore. He's thinking about math, gas left, miles to go, time remaining, and whether inland is a place you can still reach when everyone wants it at once. T-4 days. The impact zone narrows. Thursday morning brings clarity and horror. Radar refinement collapses the uncertainty ellipse to just 300 kilometers. The target is locked 150 kilometers off the coast of New Jersey, directly east of New York City. An ocean strike, the worst-case scenario for the East Coast. Computer models predict a tsunami of unprecedented scale. The asteroid will strike the Atlantic seafloor, excavating billions of tons of water and rock. The initial splash column will rise 30 kilometers into the atmosphere. Here's the terrifying part. Tsunami timing is not a Hollywood clock you can trust. It depends on bathymetry, shelf geometry, and how the energy couples into the water. In some model runs, as little as 15 to 45 minutes after our impact, the first destructive surges reach parts of the New Jersey and Long Island coastline. In others, especially where the continental shelf slows and reshapes the surge, 90 minutes after impact, the first surges strike the New Jersey coast. 120 minutes after impact, water reaches New York Harbor. The ocean won't arrive as a stereotypical Hollywood wave. It will arrive as a rapid, violent sea level rise, a storm surge on steroids, moving fast and pushing inland through rivers, bays, and inlets. The Hudson River will reverse course. Lower Manhattan, Long Island's South Shore, and the Jersey coastline will simply disappear beneath the flood. FEMA updates orders, run or rise. If you can't get 100 kilometers inland, you must find a reinforced building and get above the 10th floor. Vertical evacuation becomes the only option for millions trapped in gridlock. The nurse in Manhattan rereads run or rise. She thinks of stairwells, generators, the weight of water, and the terrifying fact that hospitals were never designed for this. T-3 days, infrastructure shutdown Friday. Governments begin systematic shutdowns. Nuclear power plants along the eastern seaboard initiate emergency scram procedures to cool reactors before the water hits. If tsunami waters breach containment, we risk a radioactive nightmare compounding the asteroid crisis. The electrical grid powers down in phases to save the hardware. The internet flickers and dies in coastal zones. Military forces mobilize to unprecedented scale. U.S. Strategic Command positions search and rescue assets far inland, ready to swoop in after the water recedes. Aircraft carriers steam full speed into the deep Atlantic, where tsunami waves will be essentially harmless swells before they break on the shore. Scientific instruments prepare to capture the impact. If humanity survives, the data will be invaluable. Ground-based telescopes, orbital satellites, and seismic buoys tune their sensors to the Atlantic. The father in Queens finally abandons the car. So do thousands of others. Some walk, some run. Some just sit on the curb like the world has paused and forgotten how to unpause. T-2 days, the eyes in orbit Saturday morning. With 48 hours remaining, NASA realizes they need visual confirmation of the asteroid structure to predict the tsunami's severity. Launching a new rocket is impossible. There isn't time to fuel and calculate a launch window. Instead, they turn to assets already in the sky. Mission Control sends a risky command to a classified reconnaissance satellite in low Earth orbit. Engineers override safety protocols, burning the satellite's remaining station-keeping fuel to drastically shift its trajectory. Simultaneously, the Hubble Space Telescope is slewed aggressively toward the approaching rock, pushing its reaction wheels to their absolute limit. At 14 UR GMT, the images stream down. The data is grim. Spectroscopic analysis reveals high iron-nickel content. This isn't a fluffy dust ball. It's a dense, metallic bullet. It will not disintegrate in the atmosphere. It will hit the water with its full kinetic fury. Meanwhile, evacuation deadlines pass. Transportation networks have failed. 20 million people remain in the coastal impact zone. Some are trapped. Others, the stay-behinds, refuse to abandon homes held for generations. They board up windows, stockpile water, and wait. The prison warden signs a decision he never thought he'd sign. The paper shakes in his hand. He knows whatever choice he makes will be judged forever, if there is a forever. T-minus 24 hours, the final day Sunday, the last full day of the world as we know it. At 11 a.m., the final orbital solution is confirmed. Impact location, 41.2 degree N, 71.8 degree W. Impact time, Monday, 09:47:23 GMT, plus or minus 1 second. Global communication networks broadcast continuous coverage. Psychologists appear on television offering coping strategies for existential dread. Religious leaders of all faiths deliver messages of hope or acceptance. In the impact zone, a surreal calm settles. The highways are empty now, the cars abandoned. Those who remain have made their peace. Some hold vigils on the beaches, watching the horizon. Others barricade themselves in high-rises. The nurse rides an elevator up with strangers. Nobody speaks. They all avoid eye contact, like eye contact would make it real. Humanity collectively holds its breath. T-minus 3 hours, final preparations. Monday, 06:47 GMT, 3 hours until impact. The asteroid crosses the orbit of the Moon. From Earth's surface, it is now visible to the naked eye, a new, unblinking star growing brighter by the minute. It is closing at 97,000 kilometers per hour. Seismic monitoring stations worldwide go to high alert. In underground bunkers, government continuity teams seal the blast doors. Even if Washington, D.C. is inundated, the federal government must persist. Across the zone, people make final preparations. They fill bathtubs with water. They hug their children. They charge devices one last time. The psychology of the moment is heavy, a mixture of terror and awe. The father and his son reach a concrete stairwell inside a reinforced building. He doesn't know if it's enough. He only knows it's all he has left. T-minus 1 hour, atmospheric entry. Monday, 08:47 GMT, 60 minutes until impact, 2026. AX-7 hits the exosphere. To observers on the ground, the star becomes a dazzling flare, outshining the morning sun. Shadows on the ground double. At 100 kilometers altitude, the asteroid slams into the atmosphere. The bow shock heats the air to plasma. A sonic boom, loud enough to shatter windows, rolls across New Jersey and Long Island, minutes before the rock even lands. The asteroid begins to fracture under the aerodynamic load, but the iron core holds together. It screams toward the ocean at hypersonic speed. T-minus 10 minutes, the end of the countdown. Monday, 09:37 GMT, 10 minutes. The asteroid drops below 20 kilometers. It crosses the Atlantic coastline, casting a blinding light that turns the morning sky white. People outside the evacuation zone stand on rooftops, filming the approaching doom. It is a primal impulse, to witness, to document. In the final seconds, sirens wail across the coast, a mournful harmony to the end of an era. There is nowhere left to run. Impact. Monday, 09:47:23 GMT, 2026. AX-7 strikes the Atlantic Ocean. The asteroid hits the water traveling at 27 kilometers per second. At this speed, water acts like concrete. The kinetic energy, equivalent to 320 megatons of TNT, is released in a fraction of a second. A fireball 15 kilometers wide erupts from the ocean, vaporizing millions of tons of seawater instantly. The steam explosion punches a hole through the atmosphere, rising 40 kilometers into the stratosphere. The shock wave races outward at supersonic speeds, flattening trees and shattering glass 200 kilometers away. And then the ocean recoils. After impact, the surge. The tsunami arrives not as a wave, but as a deluge. Depending on the seafloor and coastal geometry, the first catastrophic surges can arrive astonishingly fast. in the most violent model runs. 15:45 minutes after impact, the first destructive walls of water hit parts of New Jersey and Long Island. In other runs, 75 minutes after impact, the surge hits Long Island and New Jersey. A wall of turbulent dark water, choked with debris, overrides the coastline. It creates a new temporary coastline miles inland. Everything in the red zone, buildings, vehicles, the remnants of cities, is ground away. The water rushes into the streets of Lower Manhattan, swirling through the canyons of Wall Street, turning subways into cisterns. But millions survive. The evacuations worked. The vertical shelters held. Search and rescue operations begin immediately. Military helicopters swarm in from the west. First responders who hunkered down in fortified inland stations deploy boats into the flooded streets. The death toll is catastrophic, but without the 7-day warning, it would have been an extinction-level event for the region. In a stairwell above the 10th floor, the nurse listens to the building groan. In the dim light, strangers become a community in real time, sharing water, sharing phone chargers, sharing silence. The father holds his son so tightly, it's like he's trying to anchor him to earth. What we learned 7 days was not enough time to stop the asteroid, but it was enough to save the future. The coastal cities are gone, perhaps for decades, but the nation survives. The difference between survival and total ruin came down to detection. This scenario is not hypothetical. Astronomers have already found tens of thousands of near-Earth objects, and the catalog grows every year. But mid-sized impactors can still slip through the glare of the sun, hidden by bad angles, bad timing, and the limits of our sensors. Detection is our only defense. We need to find them not 7 days out, but 7 years out. Because next time, we might not get a warning. Next time, the sky might just go dark.